Tends is our next example, second example in 1.7, where we're solving problems involving slightly more complicated objects. So excuse the quality of my diagram here, but this is supposed to be a cylindrical shape with then a half of a sphere on top of it. So hopefully you can picture that. I think the labeling helps a bit. And we're given some dimensions there. The surface area of this is going to be a bit tricky because we certainly don't have a formula for that directly. We have surface area of a cylinder and surface area of a sphere, but if we're silly enough to just add those two together, certainly we're neglecting a lot of what's going on. And even if we divide that sphere area in half, since we have a half of a sphere, we'll be neglecting one big piece of it. So the important thing to realize is that each of these is in their formula for a reason. The reason why there's a 2 pi r squared in the surface area of a cylinder is because we do the top circle and the bottom circle of a cylinder. And then the 2 pi rh is the round outside part of the cylinder. The sphere, a little bit different, kind of you do the whole thing at once. But for this particular question, I had to make up my own formula. And the reason why I did what I did, I'll explain. So I'm only going to have 1 pi r squared rather than 2 because my shape only has a circle on the bottom. The circle that would have been the top of the cylinder is now covered by that hemisphere. So I have pi r squared for that bottom. I still have the 2 pi rh, which is the lateral area around the cylinder. The round part is still there. And then I will take the 4 pi r squared that's normally a sphere's surface area and divide it in half, because I will have half of the area of a sphere. And notice again, the face where it's touching the cylinder doesn't get counted. That's not on the surface. So if I crunch the numbers, put in my numbers here, I've got a radius of 5 and a height of 10. Those are the only two quantities I needed. So I've got pi r squared for the bottom, 2 pi rh for the lateral part of the cylinder, and then 4 pi r squared divided in half for the area of the hemisphere. I can crunch those numbers even if I just do 25. 5 times 5 is 25. 2 times 5 times 10 gives me 100. And then 4 over 2 times 5 gave me 50. So I have a lot of pi's here. So I could even answer that as 175 pi. But in your case, they usually give you some rounding instructions, and we multiply 175 times 3.14, blah, 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 and we get about 550 square meters. But the really key thing here is figuring out how in the world do I decide what areas I have and what areas I don't have in terms of the individual formulas for surface area of those shapes.